Okay, so step 1, take the second derivative. That's driving me crazy. I'm writing on the paper, but there's like a million papers underneath it, so it won't lay flat. Take second derivative to that. Okay, so this is my first derivative, right? So I'm going to take the derivative of this. It's going to be the derivative of the top, which is going to be negative 2x times the bottom, x squared plus 1 squared, minus the derivative of the bottom. Okay, the derivative of the bottom is tricky. You're going to have to use chain rule. The 2 would come down, the x squared plus 1 would stay, and then you'd have to multiply by the derivative of the inside. And I ran out of space on the paper, so I'm going to just write the top right here, which is not very helpful, but better than not putting it. All over the bottom to the 4th now, because it's squared. Now, did I get that 4 from adding 2 by 2 or from multiplying 2 by 2? Powers to powers multiply. Cool? Okay, so now that I have this, I'm going to write it one more time so that it's actually legible.
I was right there with you, man.
Well, so it's actually on one line, maybe?
Add, subtract.
Do a backflip.
Take up the whole line. That's okay. Now notice that I have an x squared plus 1 and an x squared plus 1 in every single thing. So I can cancel one out here, here, and cancel one out here. And then if I rewrite it, I would have negative 2x, x squared plus 1, minus, I'm going to put these two together, 4x times 1 minus x squared, all over x squared plus 1. Now, because I have to find critical points,
To the third.
oh, I'm sorry, thank you, to the third. Because I have to find critical points, I'm going to simplify I'm going to put everything I can as a polynomial for the top, because I'm going to have to solve it for 0. If I was just taking the second derivative to give them an answer what the second derivative is, I'd be done. Make sense? I don't know if you got it, but I think you do. I'm going to multiply. Actually, I'm going to take a negative 2x out. So I'd have an x squared plus 1 plus 2 times 1 minus x squared. You guys following me? Negative 2 out, so then let's lose that. So I'd have a 2 left there, but it'd be a positive 2, and this is still left. I'm going to multiply this through. So I have to make sure I don't skip steps. I always get so frustrated when my TAs skip steps. I'm like, I'm coming to you for help. How is it helpful when you leave me? 2x squared. So, is that good? I think it's right. So then, I would have x squared minus 2x squared, which is a negative x squared plus 3, over x squared plus 1 cubed. I'm going to set the top equal to 0. I'm not going to bother with the bottom, because I already know that it never equals 0. Cool? So we're on step 2. Set top and bottom 0. Okay, so negative 2x times 3 minus x squared equals 0. See, I just flipped that. Same thing though. So that gives me negative 2x equals 0, and 3 equals x squared, or x equals plus or minus the square root of 3. So this gives me x equals 0. So number 3. I'm actually going to go on to the next page. Just, is anyone not got in the row? Okay, thanks for paying attention for me. I'm going to actually do 3 on the next page. So first I'm going to write down x equals 0, x equals plus or minus square root of 3. And we know that the second derivative is negative 2x, 3 minus x squared, over x squared plus 1 cubed. Everyone happy? Great. We're going to now do a number line. Okay. Okay, and I'm going to plug in numbers above, between, below. Okay? What's a number bigger than the square root of 3? I say let's try 3. 2 is not bigger than the square root of 3, is it? Square root 3. It is bigger. You're right. Okay. Oh, of course. Thanks. So I'm going to plug in 3 above 3. I'm going to plug in 1 between, -1 below, and -3 below. Is that okay? Hope that's okay. So if I plug 3 into this, that's going to give me a negative out here. That's going to give me a negative in here. Right? So negative times a negative is, and the bottom is always positive. If I plug in 1, I'd have a negative and a positive, which would make a negative. If I plug in a -1, I would have a positive times a positive, so that would be positive, right? And if I plug in -3, I'd have a negative times a negative, which is a positive. And then this would be a negative. So positive times negative would be a negative. Everyone okay so far? So a minus sign on the second derivative means concave down, this means concave up, this means concave down, and this means concave up. So that means I have points of inflection. Didn't right. Let's try that again. Points of inflection at -√3, and then I don't know what if I put -√3 in there. That would be -√3 over 3 plus 1, which is 4. Yeah? So it would just be -√3 over 4. If I put 0 in, I would have 0, 0. And if I put positive square root 3 in, I'd have a positive square root 3 over 4. And that is what I think that they would have you do. Tricky part about this. These relative min and max are also absolute min and max. They're absolute min and max because if you look at the original problem, is the power on top higher or is the power on bottom higher?
Bottom.
When the power on the bottom is higher, that means that the limit as you go to infinity goes to 0, which means you have a horizontal asymptote of 0, which means this graph looks something like this. Now you don't have to be able to graph, but I just wanted to do this problem because it does pretty much everything you need to know from this section in one fell swoop. Everyone got it? Tricky, but doable. Okay. Now I think we should do, let's look. I think we need to do, we need to do a couple, let's do 2 story problems, a box and a triangle, and then let's do an implicit differentiation, geometric series, Taylor series, and then I think we can go on to test 3. Sound good? And if we magically get done before our 2 hours is up, I'm happy to hang out and let you ask me as many questions as you want. No screening necessary. Sound good? I think that's a fair deal. Okay, that was number 8, right?
We still have another half hour.
Okay, we're on page 9. Story problems. Oh, so much fun. Okay, story problems. I'm looking at 6.2. I think that you guys should know how to do. I think that these are problems that if you don't know how to do, you should definitely learn how to do. I think that you should do, I think 13 is a good one. Let me just read it all the way. Yeah, I think 13 is good. I think if you don't know 16, then you're in trouble. I think you should know 26. And I've never seen them ask a question with a cylinder on it, but just in case, you should do number 20. I think that's it. Oh, 23. We should do 23.
Just redo that.
23 is just fun because I get to tear out paper, and they like to put it on the
No
test.
kidding, huh?
Okay. Yes. Do you want another paper? Here, why don't you use the derivative one that I messed up? You can just sign on the back.
Well, we haven't got it.
It needs to go back. Magic.
Don't worry about it.
Okay. Okay, we're gonna just do, I think of x comma y. That means x and y are independent, which means y is not a function of x, which means that you don't need to use implicit differentiation. If they don't tell you that they are independent variables, you must assume that y is a function of x. In fact, this tells you to say that y is a function of x. Okay? Also, they would have d's here instead of del, which is that funny 6 thing. Okay? So I just want to make sure you can tell the difference for your final, because I want everyone to do so well. All right, so first of all, we've got a product rule going on here. So we'd have the derivative of the first. Did it work, Scott?
Yes, could be.
Rock star, Amanda, rock star. Derivative of the first times the second plus the first times the derivative of the second. This is tricksy. Notice the dy dx showing up. Is it okay if I just, I'm going to chuck a squared up there just because I can, and I think it might help you guys with the, I think it's harder, and I think it's good. This 2 would come down, so it would be a -6. The y would stay, you subtract 1 from the power, and then you do the derivative, that's a 1, not a prime. Then you do the derivative of the inside, 0. Okay? No, because the derivative of 9 is. That's okay. All right, we okay so far? Kind of harsh. Next thing we're going to do is everything that does not have a dy dx is put to the other side. So this stays 3x e to the y dy dx minus 6y dy dx equals a -3 e to the y. Next step, we factor out a dy